Now we will see the terms which are used in helical spring. Now the first term, that is solid height or solid length. In this here you can see there are the three diagrams A, B, C. So we will see one by one the explanation of each diagram. So the first is the solid height or solid length. What it is? The product of total number of coils and diameter of wire, where it is denoted by LS, where LS is for the solid length and which is equal to N dash into T, where N dash is what? It is the total number of coils and D is the diameter of spring wire. Now solid height or solid length is calculated by means of this formula. Now the second diagram is of free length. The length of spring is a free or unloaded. So what is free length? When your spring is not loaded, it is unloaded one, or free one is called as a free length. So now it is denoted by LF, where LF is equal to solid length plus maximum deflection plus clearance between adjacent coils, where LF is equal to N dash into D plus delta max plus 0.15 delta max. Okay, that clearance between adjacent coils should be taken as 0.15 of delta max, and maximum deflection will be of delta max, and solid length is what? N dash into D. So from about these three diagrams, the first diagram, A diagram, shows the spring which is in a uncompressed position, that is free from any unloading, which is free from any loading. So that is first diagram shows the free length. Now once we will get compressed by means of delta, so here you can see in B diagram there is a compressed length. W is applied from the top side as well as from the bottom side, and in C diagram, that is totally it is compressed, so that compressed solid length you can say. So the first diagram shows free length and the solid length shows in a C diagram. So delta is the deflection and delta max is the maximum deflection. When the coils will get connected or get touched to each other, then you can say as a solid length, and in first diagram when it is in uncompressed condition is called as a free length. Now the third definition, spring index. What is spring index? It is the ratio of mean diameter of coil to the diameter of the spring wire, and generally spring index is taken from 5 to 10, where C is equal to, and now spring index is denoted by capital C, where C is equal to capital D by small d, that is the mean diameter of coil to the diameter of spring wire, where capital D is the mean diameter of coil and small d is the diameter of spring wire. Now the fourth definition, spring rates or stiffness or the spring constant. The load required per unit deflection of the spring is called as the spring rate, where stiffness spring rate is equal to W upon delta, that is W load which is applied and delta is the deflection. And the last definition, fifth one, or the term, the axial distance between adjacent coils in uncompressed state, that is P, it is denoted by P, where P is equal to free length divided by N dash minus 1, where N is nothing but total number of coils. Okay, so you can find out P, that is pitch. Pitch is nothing but distance between two adjacent coils, that is free length upon N dash minus 1. Now the material for spring. Now what are the various types of materials are used for manufacturing of the spring? The plain carbon steel, alloy steel, corrosion resistant steel, non-ferrous spring material, that is phosphor bronze, brass, nickel, alloy, beryllium copper. Okay, so these are the various materials are used. The patented and cold drawn steel wires, oil hardened and tempered spring steel wires, that is chromium, vanadium or solid manganese. These are the various types of materials which are used for the spring. Now the next, the desirable properties of the spring material. Now what are the main or desirable properties of that spring? The first one, it is high resilience. Then second one, it is high static strength. Third one is having high fatigue strength. Fourth one is non-corrosive. On fifth one, it is ductile one. So these are the various desirable properties of the spring material. Now manufacturing of the spring. The next point, how to manufacture the spring. So the springs are manufactured by hot and cold working process. So generally hot and cold working process is used for the manufacturing. The small size springs are manufactured by cold working and large size springs are manufactured by hot working process. So during the winding, internal stresses are induced which can be relieved by suitable heat treatment process, So again, and pre-hardened wires should not be used for spring with spring index less than 4. So the heat treatment process is applied after the formation of wound and quenched by oil to improve the mechanical properties. So the toughing treatments carried out to improve the resilience and toughness. So these are the various care or the various process you need to consider while manufacturing of the spring. Now we will see the various types of springs ends for the helical compression spring. So now there are various types of spring ends are there. So now which types of the spring ends are used for the helical compression spring, that we will see one by one. Now here in this diagram you can see the first diagram, the plain end type spring is used. In second, plain and grounded type of a end. In third diagram, the square type of a end, and in fourth diagram, squared and grounded type of a end. So these are the various four types of spring ends are used for the helical compression spring. So the spring ends are formed according to the surface on which it rests and loads are applied on it. If the end of the spring is not proper end, then eccentric load may act on the spring, and due to which the maximum stress will be induced on the eccentric end. So hence, to avoid this effect, the end of the springs have to be manufactured according to the application. So here you can see, as per the application, you can select the spring or you can select the end type of the spring. Now again we will see that ends of the spring one by one. So the first one, the plain end. Second one is a plain and grounded end. Third one is a square end. Fourth one is a squared and grounded end. Again, now there are the two terms, inactive and active coil turn, that we will see now. Now first we will start with the plain end. What is plain end? When to use that plain end? The load axis when does not coincide with the axis of the load, in that case they are not much used in practice. So the load axis does not coincide with the axis of the load, that's why it is not majorly used in applications. Now second one, plain and grounded end. The spring which ends ungrounded and flattering and made the sufficient seat area for the spring support. So in this eliminates the drawbacks of the plain end. So here it eliminates the drawbacks of the plain end. Now the third one is a square end. So in this, the end coils are pressed such that they become square to the axis of the spring. So due to this, total seat area for spring support increases, but as the ends are not grounded, so the proper seating is not available in the square end. Now fourth one, squared and grounded end. In this, the end coil are pressed such that they become square to the axis of the spring and grounded. Now next term is inactive turns. What is inactive turns? The part of a coil which is in contact with the seat and do not contribute in a spring action is said to be inactive, and these turns involved are called as a inactive turns. And what is active turns? So the turn which takes part in a spring action are called as a active turns. So these are the two terms are the very important one, inactive and active turns. Inactive means the spring coil which does not take part in a contributing to the load which is coming on that particular spring, and that particular coil is called as a, or turn is called as a inactive turn. And active turn is what? The spring coil or a spring coil which come in contact when the load is applied on that particular spring is called as a active turn. Now as per the types of end and total number of turns, if it is a plain end, then you have to take n only, that is active turns you have to consider. If it is plain and grounded end, again you have to consider n only, that is total number of turns will be n. If it is of square end, then it is n plus 2. If it is of square and grounded end, it is again n plus 2. Now here is the types of spring end for the helical tension spring. In this diagram you can see the various types of a spring end, that is full loop type, small eye type, plain square cut end type, long round and hook type, and V hook type. Thank you.